Let's do another example on Fourier transform. The, the time domain function in this case is a rectangular pulse with duration tau as given in this figure. The pulse magnitude is 1 for t between tau over 2 minus tau over 2 to plus tau over 2, and the notation to denote this rectangular function is rect t over tau. Applications of such a function can be found in digital communications and signal processing. In digital communications, waveform representation such as NRZ and RZ coding of digital ones and zeros in time domain is a kind of rectangular pulse. For instance, in NRZ-L coding, rectangular pulse with positive value is used to represent binary 1. In signal processing, ideal low-pass filter with cutoff frequency of omega c is a rectangular pulse in the frequency domain. For deriving the Fourier transform of this rectangular pulse, we start with the definition of Fourier integral x of omega, that is from minus infinity to plus infinity, x of t e to the power minus j omega t dt. Replacing x of t by rect t over tau, we can further simplify the integral, substituting the value of rect function 1 in the time interval that is non-zero. So we replace the lower limit of the integration by minus tau over 2 and upper limit by tau over 2, and that is straightforward to integrate, and result we get this guy. So this is quite unfamiliar term that we need to further simplify it. Remembering the Euler identity of sine theta, that looks like this Euler expression, looks like this expression. But we need to make further simplification. Multiplying the numerator and denominator by 2 and moving the j inside the parentheses, we get the Euler expression of sine omega tau over 2 inside the bracket. Then we further simplify this, that is 2 sine something divided by omega, and remembering the definition of sinc function, sinc theta, that is sine pi theta over pi theta, we want this expression sine omega tau over 2 over omega to look like the definition of sinc theta. So in order for that, defining theta as omega tau over 2 and multiplying the numerator and denominator by proper parameters or values, so we get this guy, and this guy is exactly equal to tau sinc omega tau over 2 pi, and that is the Fourier transform of this rectangular function. So we can also denote this as Fourier transform pair as given in this equation. Fourier transform of rect t over tau is tau sinc omega tau over 2 pi. So plotting this sinc function, we get this figure in this figure, in this sinc function, it has maximum value at omega equals 0, that is tau, and the side lobes of this function decreases as omega increases, and this function has 0 values at multiple of 2 pi over tau. And one thing we can notice here, that this Fourier transform is real valued function, and that's because the time domain function rectangular t over tau is even symmetric function. So from this example we can deduce that for a function in time domain that is even symmetric, the Fourier transform of this function is real valued.